The year is 2025. We look up at the familiar night sky, seeing the moon and the stars. Now imagine rewinding 66 million years. The sky was the same, but the planet below was utterly alien, dominated by giant creatures whose rule had lasted an incredible 165 million years. Then, in what was a blink of an eye, geologically speaking, they vanished. For decades, the standard explanation was simple. A massive rock struck the Earth, and the dinosaurs died. Yet, that neat narrative hides a much more complex and painful reality. The asteroid wasn't the sole agent of death. It simply paved the way for a slower, far more agonizing global collapse. The critical question isn't just what hit the Earth, but how the planet itself turned hostile against its mightiest inhabitants. What if the impact only set the stage for a prolonged, devastating global death? Today, the scientific consensus points to the Chicxulub impactor, a space rock roughly 6 to 9 miles wide, as the central trigger. The evidence is overwhelming, primarily found in what geologists call the KT boundary, or more accurately, the KPG boundary. This is a thin, distinct layer of sediment discovered globally, marking the exact moment the Cretaceous period gave way to the Paleogene. This layer is rich in iridium, an element rare in the Earth's crust, but abundant in asteroids. It is the unmistakable calling card of an extraterrestrial killer. The impact was an unimaginable catastrophe. The energy released was equivalent to billions of atomic bombs going off at once. The asteroid slammed into the Yucatan Peninsula in modern-day Mexico, forming the 110-mile-wide Chicxulub crater. Immediate death occurred for miles around, but the real destruction was worldwide. Massive shockwaves triggered earthquakes globally. The resulting seismic activity would have made the 1906 San Francisco earthquake feel like a slight tremor. Superheated debris shot into the atmosphere, causing firestorms that wrapped around the planet. Forests exploded into massive infernos, creating the conditions for the true extinction mechanism. The asteroid strike launched trillions of tons of pulverized rock, soot, and, crucially, sulfur from the impacted gypsum rock into the upper atmosphere, the stratosphere. This material didn't just fall back, it lingered, creating a planet-wide dark veil. The result was an unending, suffocating global winter. For months, possibly years, sunlight struggled to pierce the atmospheric haze. Global temperatures plummeted, photosynthesis completely halted, and plants, the base of every terrestrial food chain, began to wither and die. This environmental breakdown was the real executioner. The largest animals, like the plant-eating sauropods and ceratosopians, starved first as their food source vanished. The carnivores that hunted them quickly followed, trapped in a cold, dark, and increasingly barren world. At the same time, the vast quantities of vaporized sulfur condensed and rained back down as powerful acid rain. This acid rain poisoned fresh water sources and drastically acidified the surface of the oceans. The microscopic organisms, plankton and algae at the bottom of the marine food web died off, causing a rapid collapse of ocean ecosystems. This long, slow environmental poisoning turned a sudden strike into a prolonged planetary ordeal, shattering life both on land and at sea. To further complicate this story, the Earth was already under immense strain before the asteroid arrived. In modern India, a massive volcanic episode known as the Deccan Traps had been erupting for hundreds of thousands of years leading up to the KT extinction. These volcanoes spewed out vast sheets of lava and, more importantly, huge amounts of greenhouse gases and sulfur into the atmosphere. While the asteroid delivered the fatal blow, the Deccan Traps eruptions had already severely destabilized global climate and chemistry. They had warmed the planet and weakened many species' natural resilience, making the biosphere hypersensitive to the subsequent asteroid impact. The Deccan traps were the slow fever, and the Chicxulub intact was the sudden, deadly infection. So what truly destroyed the dinosaurs? It was a terrible convergence of events. An asteroid impact that triggered the devastating combination of global winter and acid rain, striking a planet already weakened by massive, ongoing volcanism. It wasn't a swift execution, but a systematic environmental collapse. The animals that survived were typically small, able to burrow, hibernate, and eat almost anything. Many mammals, turtles, crocodiles, and critically, birds, the direct descendants of the dinosaurs, managed to make it through. The Great Extinction was a great reset. It was the moment the old world died so that the new world, ruled by mammals, could begin. If you enjoyed this video, hit like and subscribe for more amazing science. And as always, stay curious.